Pop culture generally views Atlantis through the lens of fantasy. We imagine glowing crystals, undersea kingdoms, and mountains of mythological gold. However, the descriptions provided by ancient writers focus on precise geometric measurements and concentric layouts, details that mirror a modern engineering schematic. A system architect looks past the aesthetic and searches for the functional requirements, the mass transit, the thermodynamics, and the waste loops. Our goal is to reverse engineer this ocean-bound capital from the bedrock up to see if it could actually function as a zero-waste physical machine. Removing the fantasy reveals a blueprint for circular infrastructure, a model for how a closed-loop megacity handles its resources. This top-down schematic shows 3 alternating rings of water and 2 of land, a concentric ring resonator. The foundational rings were built with granite, packed with quartz crystals. Under immense mechanical pressure, these crystals generate a steady electrical charge through the piezoelectric effect. Capturing this charge requires a medium capable of holding it. Water is an effective dielectric fluid, particularly when it is highly mineralized. By placing rings of salt water between the pressured land masses, the architects created massive, natural capacitors to capture and store the Earth's telluric currents. To move power into the city, the central core's interior walls were coated in orichalcum, a refined copper alloy. Functioning as a low-resistance busbar network, it carried harvested electricity from the granite foundations directly into the center. The architecture functioned as a solid-state energy system, converting natural tectonic pressure and salt water into a self-sustaining power grid. A high-density metropolis located in the ocean faces a specific vulnerability: the management of its waste loop. If waste contaminates the saltwater capacitors, the resulting voltage drops would crash the entire power system in a matter of weeks. Moving mass quantities of gray water away from the center requires a system that does not rely on external electrical pumps. This profile elevation graph shows the hydraulic gravity step-down. Built on an outward-sloping gradient with the core at the highest altitude, this slope allowed the sewage network to run on zero external power, using gravity alone to pull gray water away from the center. The subterranean channels utilized hyperbolic curves rather than standard piping. This design minimizes friction and prevents the accumulation of debris. These channels functioned as vortex separators. The spiraling flow used centripetal force to naturally separate solid waste from the liquid stream. The separated waste was routed to the outermost perimeter, entering deep filtration chambers packed with highly porous basalt. Within these chambers, mineral-consuming microbes neutralized pathogens and converted organic material into sterile, nutrient-rich fertilizer for the agricultural plains to the north. This fluid dynamic system kept the water capacitors pristine while simultaneously turning the city's waste into agricultural fuel. Looking at the assembly as a whole, the city operates as a single, continuous physical machine. The architectural takeaway is that a functioning ecosystem requires a completely closed loop. In this model, power generation and environmental maintenance are not separate departments. They are parts of the same integrated circuit. Every watt of energy harvested was directly dependent on how cleanly the population managed its resources. Whether Atlantis existed as a historical location or an ancient thought experiment, its value lies in its logic as an engineering schematic. As we design the smart cities of the future, we can look to this model to see how technology can be grounded into the natural, closed-loop geometry of the Earth.